Let's learn fluid flow. Have you ever wondered why water flows smoothly in a tap but turns messy when fully opened? Or why airplanes are tested in wind tunnels? The answer lies in understanding streamlined and turbulent flow and the amazing concept called Reynolds number. Streamlined laminar flow. Water in a narrow pipe. Blood flow in small arteries. Oil flow in thin capillaries. In streamlined flow, fluid particles follow well-defined paths called streamlines. At any point, the velocity vector is tangent to the streamline. 1. A fluid flow is said to be streamlined when each fluid particles follow a definite path and these paths do not cross each other. Here you have a pipe. The fluid flows through this pipe. Two, velocity of each particle at a point remains constant over time. Point A, whatever the particle comes to point A, it must take the velocity 2 meter per second. If it goes to point B, it must take 5 meter per second velocity. If it goes to point C, then it must take 3 meter per second velocity. Velocity of each particle at a point remains constant over time. 3. The streamlined is defined as a path in a fluid such that the tangent at any point gives the direction of the fluid velocity at that point. The streamlined is defined as the path of a fluid such that the tangent at any point gives the direction of fluid velocity at that point. At A, the direction of velocity is the tangent at the point A to that curve. At B, the tangent at B to that curve gives the direction of fluid velocity at that point B. Similarly at point C. 4. In a steady flow, streamlines are stationary curves and don't intersect. Flow in a narrow pipes at a low velocity is usually streamlined or laminar. A group of streamlines form a tube of flow. Fluids don't mix between tubes. It's like traffic in a separate lanes. Tube of flow. 1. A group of streamlines forming a cylindrical region is called tube of flow. So in our diagram, we have one tube. 2. Particles remains confined within their tube of flow and cannot cross over to adjacent tubes. 3. The axis of the tube is itself a streamline. Turbulent flow. Water behind a boat. Look at how the water behaves behind the fast moving boat. Similarly, smoke from a chimney turning chaotic. When the fluid speed increases beyond certain point, flow becomes irregular and random. This is turbulent flow. It contains eddies, swirling currents, causing energy loss due to friction. The first point, when the flow speed exceeds certain limit, the fluid particles moves in irregular and random paths. Here you have a tube. The lines intersect, moves in different velocity. 2. The velocity of a particle at a given point fluctuates continuously in magnitude and direction. The velocity of a particle at a given point fluctuates continuously in magnitude and direction. 3. Characterized by eddies and swirls. 4. Associated with energy loss due to internal friction. Example: flow of water from a fully open tap, or air behind a speeding vehicle, or the examples for turbulent flow. Critical velocity Vc. The transition from streamlined to turbulent occurs at a specific speed called critical velocity. The transition from streamlined to turbulent occurs at a specific speed called critical velocity. It's influenced by viscosity, density, and pipe diameter. The first point: the critical velocity is the maximum velocity up to which the flow remains streamlined. The critical velocity is the maximum velocity up to which the flow remains streamlined, beyond which it is turbulent. Beyond critical velocity, the flow transitions to turbulent. 3. Critical velocity depends on fluid properties like density, viscosity, and pipe dimensions like diameter but not length. Reynolds number, RC. To predict the nature of flow, we use Reynolds number, a formula that combines density, velocity, pipe diameter, and viscosity. 1. This Reynolds number is introduced by Osborne-Reynolds. Dimensionless number used to predict flow type. RC equals rho Vd upon eta. Here, rho is the density of the fluid, V flow velocity, d diameter of the pipe, and eta the viscosity of the fluid. RC equals rho V d upon eta. RC equals rho V d upon eta. When RC is less than 1000, then the flow is streamlined laminar. When RC is in between 1000 and 2000, then the flow is transitional unsteady. When RC is greater than 2000, the flow is turbulent. Law of similarity. Here you have a car. This is in a windpipe. The wind velocity is V. The diameter of the car, the height of the car is d. Then the Reynolds number RC equals rho V d upon eta. Let us take another car in the same tunnel, but the car size is d by 2 and the wind speed is 2v. Now the Reynolds number RC equals rho 2 times v multiply d upon 2 divided by eta. In both the system, we have same Reynolds number. The system right now equal. What's amazing is that two different systems can behave the same if their Reynolds numbers are equal. This is called law of similarity. Instead of having two cars, here we have two pipes. In one pipe, the diameter is d, and in the second pipe, the diameter is d by 2. In the first pipe, the fluid flows with the velocity v, whereas in the second pipe, the fluid flows with the velocity 2v. Both are same liquid, therefore they have same density and they have same viscosity. Now these two systems behave same. 1. If two different fluid systems have the same Reynolds number, their flow patterns are dynamically similar. If two different fluid systems have the same Reynolds number, their flow patterns are dynamically similar. Widely used in engineering designs, aerodynamics, naval architecture. Enables testing of scale models in wind tunnels and water channels. Real world applications. Designing aircrafts, submarines, pipelines, and automobiles for minimal drag. This is aeroplane inside a wind tunnel. Here you have the submarine, a pipeline, and a car. Medical field, predicting blood flow behavior in arteries, lamina or turbulent. Predicting sediment transport in rivers and estuaries. Quick recap. Streamlined means smooth and predictable. Turbulent flow means chaotic, random. Critical velocity decides the transition of streamlined to turbulent flow. The Reynolds number Rc predict the flow type. Similar Reynolds number means similar flow behavior.